Hello and welcome to this lesson on an introduction to electricity, which is part of the electricity topic in GCSE AQA physics. So in today's lesson, if we've been successful and we've learned today, we should be able to understand the definition of current and potential difference, link resistance into the concepts of current and potential difference, and calculate values of current, potential difference and resistance in an electrical circuit. So we're going to be looking at the following parts of the AQA GCSE physics specification. And this includes current, resistance and potential difference. Now, to understand the physics behind electricity, you must consider the electron. Electricity can be described by the behaviour of electrons in materials. However, the behaviour of the electron is determined by its charge. Now, all mobile charged particles can produce the phenomena of electricity, and electrons are the most common mobile charge carrier in the universe. So we can start understanding electricity by considering a metal wire such as copper. Now, metal wires are full of free electrons, and free electrons are examples of mobile charge carriers in electrical circuits. So free electrons are electrons which are not bound to any nucleus or ions. Now, the greater the number of mobile charge carriers, the better the electrical conductor. So this makes the free electron a mobile charge carrier, as they have a charge and they can move throughout the material. Now, due to metallic bonding, the outer shell electrons in a metal become mobile charge carriers. Now, it's really better to refer to electrons as mobile charge carriers, as this allows other charged particles to produce a current. Now, electrons can be mobile charge carriers as they have a negative charge. So electrons are very small, fundamental particles and have a negative charge. We can use the charge of an electron to force them to move in the same direction in a material. So a current flows in metal wires as when mobile charge carriers in the metallic structure are all moving in the same direction. Now, if there was no current in an electron, you would still get electrons moving naturally, which is called electron drift. So a current flows in a metal wire when those mobile charge carriers in the metallic structure are all moving in the same direction. Now, charge will flow at different rates in different objects. Now, charge carriers must have a charge to be able to form a current. Now, electrical charge is a property of a particle which determines whether or not it moves in a current. So, for example, an electron has a negative charge. Now, all charged particles move in a current if the potential difference placed across them is in an electrical circuit. Now, we can place a force across a wire which can make the mobile charge carriers want to move in a direction. Now, the electrons will want to move towards an opposite charge such as a positive and move away from the same charge, a negative. Now, a potential difference is provided by a battery or a power pack or the mains electricity. So the electrons are repelled by the negative charge placed across the wire and attracted to the positive charge placed across the wire. And as you'll see, they'll all flow in one direction. So for an electrical current to flow through a closed circuit, the circuit must include a source of potential difference. A potential difference causes the current to flow when there's a complete circuit. So a potential difference is the ability for the mobile charge carriers to do work in the electrical circuit. It's the amount of work done per unit charge inputted into the circuit. Or you could think of it as the amount of work done per unit charge outputted through a component in the circuit. Now, all materials which have a current traveling through it will have electrical resistance. Now, in a metal wire, there are also metal ions in the wire as well as mobile charge carriers. The mobile charge carriers will collide with the metal ions and they slow down. Now, the mobile charge carriers knock into the ions and slow down, so this lowers the current, and this is the idea of resistance. Now, the more blocking of mobile charge carriers, then the more the resistance. And there are many ways to alter the number of collisions between the mobile charge carriers and the metal ions and change resistance. Now, during each collision, some of the electron's kinetic energy is transferred to the lattice of the positive ions. This increases the vibrational energy of the positive lattice, and this raises the temperature of the metal. Now, if the energy transfer is large enough, the conductor may get hot enough to glow. Now, this is how an incandescent light bulb, kettle and toaster work. So we can summarise these concepts with the following picture. The current measures how the unit charge moves through the material. It measures the rate of flow of charge in the material. The potential difference measures the energy needed to move the unit charge in the material. The potential difference measures the energy given to each unit charge to move in that material. Whilst resistance measures the difficulty the charge have in flowing in a material, it's that proportionality constant between PD and current. It is also the difficulty of converting the energy given to the charged particle into movement. So the higher the resistance, the lower the current, as the charge finds it more difficult to move. The higher the resistance, the higher the potential difference, as more energy is needed to move the charge through the material. Now, electrical current is a flow of electrical charge. The size of the electrical current is the rate of flow of the electrical charge, and this is given by the following equation. Current is equal to charge over time. Current is measured in amperes, charge is measured in coulombs, time is measured in seconds, which is always the case in physics. Now, current is the same at any part of a series circuit. The electrons do not speed up or slow down in a wire. Current splits when it encounters a junction, so the electrons will split equally about the path which to take. Now, this equation must be memorized for your examination. Now, potential difference is the work done per charge to move charge around an electrical circuit, and it's given by the following equation. Potential difference is equal to work done over charge. The potential difference across the circuit is measured in volts. The work done, carried out by the charges, the electrons, is measured in joules, and the charge being moved in the electrical circuit is measured in coulombs. The potential difference can be considered the driving force pushing the charge, the electrons, around the circuit. The potential difference in a closed loop of electrical circuit has an overall value of 0. The potential difference put into the circuit equals the potential difference out of the circuit. This is because energy cannot be created, energy cannot be destroyed in an electrical circuit. The current through a component depends on both the resistance of the component and the potential difference across the component. This is because the potential difference provides the energy to drive the electrons, the charge, around the circuit, because the resistance of the circuit provides an impedance to prevent the electrons from moving around the circuit. So we can link this in the following equation. Potential difference is equal to current times by resistance, where potential difference is measured in volts, current is measured in amps, and resistance is measured in ohms. We can symbolize this with the equation V equals IR. So the greater the resistance of the component, the smaller the current for a given potential difference across the component. The lower the resistance of the component, the higher the current for a given potential difference across the component. So to summarize, electricity is the kinetic energy of electrons moving in the same direction. Current is the rate of flow of electrons in a circuit, and this is measured in amps. Potential difference is the work done per unit charge to make them move in a current, and is measured in volts. Resistance is the impedance of electrons moving in a current. This is caused by the collisions between electrons and the metal ions, and is measured in ohms. And charge is the property of subatomic particles that allow it to move in a current, which is measured in coulombs. So to summarize, for electrical charge to flow through a closed circuit, the circuit must contain a source of potential difference. Electrical current is the flow of electrical charge. The size of electrical current is the rate of flow of electrical charge, with the equation as charge flow is equal to current times by time, and current has the same value at any point in a single closed loop. The current through a component depends on both the resistance of the component and the potential difference across the component. The greater the resistance of the component, the smaller the current for a given potential difference across the component, where V equals IR. So if we've been successful and we've learned in today's lesson, we should be able to understand the definition of current and potential difference, link the resistance into concepts of current and potential difference, and calculate values of current and potential difference and resistance in an electrical circuit. So thank you for watching this lesson on an introduction to electricity, which is part of the electricity topic in GCSE AQA physics. Thank you so much and have a lovely day.